Y'all are about ready to be sad about this. All right, here we go. Project 1. All right, guys, here we go. Storing and searching based on key value pairs is a very common problem in computer science. We have created and developed complex data structures in order to efficiently search and sort based on these. But if I give you a set of constraints, you can actually make this a lot faster. So, first big hint for this project is you need to think about the constraints and what's going on. By the way, I forgot to start this off correctly. This is a project. It's going to be significantly more difficult than your labs. You're going to have to think about this for a long time before you start coding. I'm giving you 3 weeks. You need to start thinking about it now. When you have an idea and you get stuck, come talk to me. I pretty much expect almost everyone here to talk to me at least once about every project. So you should come to me during office hours or at some point and talk to me about the project or your idea. But anyways, our map shall map a student's first and last name to an ID. In other words, we are mapping a string to an integer. Let me scroll down to what that looks like inside the code so you understand. In other words, I'm going to call add, passing in key, which is a name, maybe a student's name, and a value, which is its ID. So I'm going to pass add a lot of these keys and values. Your job is when I ask for the key, you fill in ret with the value afterwards. And then you return if it was in there true or false if it was not in there. So that's the first operation. The second operation, well, of course, I need to know that you can remove the key, as well as we'll talk about the second one in a bit. But do you understand these two? Because that's going to be what you need to understand first. I'm adding a value, associating it with the name, and then when I ask for that key, I get back the value, which is inside of ret, because I'm passing ret by that reference. Everyone got that? All right. Our map shall map a student's first and last name to an ID. In other words, we are mapping a string to an integer. Names shall consist of an array, first a single array of characters, a combination of first and last names separated by a space. The first letter of each name shall be capitalized, the rest is in lower case. All right? In between each first and last name shall be a space. Every student's name shall map to a single 32-bit integer. All IDs will be strictly above 0. So you can use 0 to signify nothing if you need to. Keep in mind your program will be graded for both accuracy and performance. For performance, the 2 operations that will be analyzed are get, which we just talked about, retrieving an ID from a string, and then how many, which returns a number, hopefully, number of names that begin with a prefix. Let me scroll down to how many, and the example should help you understand. If we had a map that had John, Jonathan, Paul, Mark, Luke, and Joanna, and I ask how many start with Joe, well, John, Jonathan, and Joanna, so the answer would be 3. Okay? So that's what how many is doing, and then there's get, which returns the ID. It's imperative you think about how to simplify the problem with the given constraints. A general solution will not be efficient, and I'm getting the interface right here. Okay. Okay, important questions. The crux of this project is determining the data structure. I have provided a common list of first and last names. Whoops, let's go into your project. Them, first names, right here. These are all the first names I'm going to use. I'm not going to use any other first names than what is listed in this file. There's 5,163 of them. Last names. Again, I'm only going to use the last names in this file. There are 45,905.
Awesome.
All right? So, keep in mind that I can do any combination of first name and last name separated by a space from those 2 files. If you were to create an array of all possible combinations, it would take over 4.5 gigabytes. A list of all possible IDs as well would be just under 1 gigabyte for a total of 5.5 gigs of memory, which may not fit in your RAM on your computer. Maybe it does. I don't know what y'all got, but it may or may not. The main thing to keep in mind is that we are storing the IDs. There's your first big hint. We only care mainly about the IDs. To get the ID back. The name is used to index to get to the ID. That's your answer. Big one. How can we efficiently store these IDs? It's vital you think about the data structure before you start coding. I suggest drawing out some pictures if you're having problems. If you want help, come with me with pictures. I'll be able to help you from there. All right, hence we've learned about arrays and pointers. We haven't learned about linked lists, but that's okay. That should be enough to design your data structure. Do not use hash maps for this problem. First off, you'll get an instant 0. Second off, you will not solve the prefix problem. Have any of y'all used hash maps before? You have? A little bit? Don't use them for this one. They're very good for the get, but they're absolutely terrible for prefix. Plus, I'm banning them, so don't use them. You'll be judged on the memory footprint as well as performance. Okay, a little bit about memory footprint. All right, code names. If you wish to know how well you did against all of your students, give me a name, because by CSU policy, I'm not allowed to display students' real name without explicit permissions. Whatever. So I can use an alias. I've got some funny ones. You know, Code Wizard, Wombat, Beast from Beast, Code Warrior.
1337. That's my favorite lead app.
Right. Lead, Hacksaw, yeah, whatever.
Beast from Beast.
Or if you want me to just use your GitHub username, that's fine too. Giant warning, data projects are significantly, I have bolded, italicized, and underlined that word. I don't know what else I could do, except maybe make it flashing or something. I don't want to turn upside down, rotate, I don't know. They're more demanding than your labs. It's going to take you a significantly amount of time, and it's not like you're going to do it in a weekend. Well, I guess if you're good, you can do this in a weekend, but good luck. You need to think about it, right? You may be able to, you can code it. Actually, if you know, once you design it out, you can code it up in probably a couple of hours. But if you sit there and you just start hacking, it's going to take you a lot longer. It's imperative you start thinking about the data structure now. If you hit a roadblock, and you should, / you will, please come talk to me. When you talk to me, be prepared to show me what you have thought of so far. I can then guide you towards a good solution. If you come to me without an idea, I will tell you to keep thinking about it. All right? Keep in mind, there are many good solutions, there are many fair, and there is a whole slew of terrible solutions to data structure projects. Yes?
No, with these solutions, there's going to be more than like the ones you showed us in the beginning, like the binary tree and the queues. Are we going to have to, I guess, do research on? No.
You have, arrays and pointers. That's enough for this project. You can use a linked list if you want to as well, and we're going to get to that shortly. So once we introduce the linked list, if you want to use that, that's perfectly fine. Don't use anything else. No what? You can sort if you want to. That's an algorithm, not a data structure. You can do whatever algorithm you want.
That's much faster.
You can do an algorithm if you want to sort it. That's fine. I won't stop you. Your grade is going to be based on accuracy. If your program passed my test cases, and additional points will be awarded for performance. Namely, accuracy in your test cases is the first 30%. Performance of gets 30. Performance of how many is the next 30. And then what was the last one? Probably your memory. Yeah, memory footprint's your last 10%. Okay. I have written 3 solutions to this problem. A 60%, an 80%, and a 100%. I wrote these on my machine, which is actually this laptop, which has about that hardware. It actually does have 8 gigs of RAM. And I've generated some graphs for you just to show you the performance, give you an idea. Yeah. That's the idea. I'll get to that in a moment. Again, STL, you may use vector, string, list, and IOStream. All right. Vector is array. List is linked list. And of course, string does a string. You can use that. And you can use IOStream. You may use any standard C tool library tools. Don't use anything else from the STL. If I see you using map from the STL, again, hash map, hash table will be issued to 0. For this project, being how I will grade on how well you write your test cases, I wrote that up there. You're in charge of all test cases. All right. It's due, that should be 3 weeks from today. No teamwork, your work must be your own. Let's see. If I go in the objectives directory, I can do a quick, let's do events, how, we're going to do how many. That's of the function how many. Timing, 60 points. So number of queries, the idea, oh, I didn't show you the other part, but I've, inside your test cases, written tests to generate a map of a certain number of entries. That's in your tests. When I run it against, well, there's a small test, medium, and large, and this is what, the 60-point version? Yeah, 60-point version. So that's how many seconds it takes to do a number of queries on different sizes. That's a 60-pointer. Let's do an events on, let's see, how many timing 80-pointer. So time in seconds, notice it goes up to 1.8 as opposed to my other one, which went up past 16. And what was the last one, the 100-point version? Okay, yeah, it took almost nothing. That was that point, that's one, dot, 4 zeros, and then it finally hit a number. And really what this graph is telling you is that for the 100-point version, you think about it and come up with a good solution, it doesn't even matter the size. The size is irrelevant. That might actually be a pretty big hint, yes?
The size, what do you mean by the size of what?
So inside of the test file, I have programmed different sizes to be generated. The size of your map, whether I gave you 10,000, 100,000, or millions of names and IDs. All right, another piece of advice that'll help. My 60-point solution was about 200 lines. Actually, yeah, 200 lines. My 80-point solution was probably around 200, and my 100-point solution was 100 lines for the whole thing. So when I say you can do it in a couple of hours, if you design it out, you can do it in a couple of hours. Of course, some of those lines are very interesting. I'll put it that way. So that's why you need to really sit down and think about what's going on. But yeah, my best solution is only 100 lines of code for the whole project. So if you write 500 lines of code, that's okay. I understand. I don't think that's too bad. But once you hit 1,000 lines, you need to stop and think about something. You're doing something wrong. That's what I'm trying to say.
Do the most amount of work as efficiently as possible.
Right.
Yeah.
Yeah.
It's impersonal.
Yeah. Yeah. Any questions about this project? I want to stop now to give you lab time. We can talk about this again, of course, next class, which is on Tuesday. Nope. All right, start thinking about your data structure.
Yeah, that's right.
You got to think about it. Draw pictures, come talk to me.
I'll come to you with my existential crisis.
That'll be great.